All right, our first example, we're going to add and subtract polynomials. Part A and part B, one is addition. Oops, here we go. We're adding and we are subtracting. Just a heads up, we always have to be super careful with subtraction. That's where the most common mistakes are made. But when you are adding polynomials, so here we have a polynomial. It's not in standard form. We can see it's out of order, but we're going to add to it another polynomial. When you are adding polynomials together, ultimately it comes down to adding like terms. And because we want our final answer to be in standard form, I always look for the highest exponent to add first and see if it has any like terms to combine with. So if it's addition, we can just essentially ignore the parentheses and find any like terms across the whole problem. So the highest exponent I see is an x to the third power. Here we have a 6x to the third power, and here's a positive 2x to the third power. And those are our only x to the third powers. So the x to the third power does not change. With adding and subtracting, your exponents won't change. You're just going to add or subtract the coefficients. So we'll take the 6 plus 2, and we have 8 of those x to the third powers. Now I'm going to look for any x squareds, and this might have us go out of order a little bit, but that's okay. Our final answer will be in proper standard form. So x squared, I can see we have a positive x squared here, a negative 8x squared there. So the x squared won't change. We'll just add the coefficients. 1 plus negative 8 is a negative 7x squared. Now I'm going to look for any x to the first power. Here's an x to the first power. And there's not an x to the first power to add to it from the other polynomial. So that just means this plus 4x won't change. It's still part of our answer, plus 4x, but it just didn't change at all because there was no other x's to add to it. And then last, we would look for that constant term, the x to the 0 power that we don't see. Do we have any constant terms, which are just the numbers without the x's? Here we have a negative 7 and a positive 3. So negative 7 plus 3 is a negative 4. And here's our final answer from adding the two polynomials together. This may seem pretty familiar. You guys have done this before. We did something similar with adding and subtracting complex numbers in our last unit. Our polynomials are going to be a little bit more involved, but it's the same general idea. Now, what makes part B different are two things. One, we are subtracting, so we have to be very careful because we're subtracting this term, we're subtracting this term, and this term. So what I like to do with subtraction problems is rewrite this whole second polynomial and distribute that subtraction, which is going to be like distributing a negative 1. So this is going to give us a negative 2x squared y squared. This term is going to turn negative, so a minus 3x y squared. And then when we distribute a negative to a negative 2, that's going to turn positive 2x squared. Now we can treat the problem like the addition problem up here, where we are just looking for like terms to combine. So that was the one difference between part A and part B. The other main difference we have in our second problem here is we have more than one variable. So let's make sure we understand what a like term is if you have more than just your x's. So a like term is going to have the exact same variable and exponent combination. So here we have an x squared y squared. I'm just going to think about this off on the side. X squared y squared can only, think of that as a unit. It can only combine with another x squared y squared. I can see the second term has an x y squared. So an x y squared, even though y squareds are part of both terms, they're not like terms because this has an x squared and that just has an x. So this x y squared we think of as a unit. It's not the same as the x squared y squared. So it would not combine. It's not a like term. All right, as we combine like terms, we are going to order our polynomial based off of the x's. If you have more than one variable, order it based off of whatever variable comes first in the alphabet. So we're going to order it based off of x's because x's come before y's. And I'm going to look for the highest exponent of all the x's that we have. So here's an x squared. There's an x to the first power, there's an x squared. Here's an x squared, x squared. So x squared is the highest exponent that we have. So I'm going to combine anything that has an x squared with it as long as it's a like term. So I'm going to look for, do we have any x squared y squareds? So as we look through, that's not an x squared y squared, that's not. Oh, here's an x squared y squared, so we'll be able to combine with that. Let's just see if we have any others, and we do not. So those are going to combine. You have 3. Now we can think of it like addition. 3 plus a negative 2 or 3 minus 2 is just 1. Oops, but your x squared y squared does not change. So 1 x squared y squared is x squared y squared. If it helps, you can cross those off just so we know we're done looking for those. Now what we're going to look to combine is an x to the first power that has a y with the term as well. So I know that there's an x squared right here. We're going to hang on to that because here's our x to the first power that has a y as well. So we're going to combine those. We have an xy squared. I'm looking for any other xy squares, and we can see there's one down here. So 2xy squared minus 3xy squared, 2 minus 3 is a negative 1. So we're going to have minus xy squared, minus 1xy squared, or just xy squared. All right, so now if I look at what's left, here's an x squared, here's an x squared. Those are going to be like terms. So 6x squared plus 2x squared, 6 plus 2 is 8. And then just remember, your exponents do not change with addition and subtraction problems. And there's our polynomial.